Hello and welcome to a new video on IGCSE Physics Classified Paper 2. Today we'll be discussing the topic of energy and power, electric energy and power. So in previous videos, we discussed that the voltage is equal to the energy carried by 1 unit of charge. So V equals E over Q. In this video, we're concerned with E. So let's rewrite this equation to say that E is equal to Q times V. So the energy is equal to the amount of charge multiplied by the potential difference or the EMF or the voltage. Now, in order to rewrite this equation in different variables, I can utilize another equation that we previously took, which is Q equals I multiplied by T, or you might be more familiar with it as I equals Q over T. Current is equal to the amount of charge passing in 1 second, but we will utilize the form given in the top, and we will replace Q with I multiplied by T. So now we have I multiplied by T multiplied by V. How is this significant? Well, we need to understand that the energy can be expressed as charge times voltage or current times time times voltage. From previous videos as well, from mechanics even, we took that power is equal to energy over time. So power is equal to I multiplied by T multiplied by V over time. We can cancel out T and T, and we get IV. So to summarize, we have two equations that we are interested in retaining. Energy is equal to charge times voltage, or current times time times voltage, and power equals current times voltage. These two equations are important, and we shall be using them throughout the rest of this video. Let's begin answering some questions. What is the unit of electrical power? Electrical power or mechanical power or any sort of power is measured in watts. You should know that from mechanics. So the correct choice here would be choice D. A resistor of resistance R connected to a battery of EMF V. There is a current I in the resistor. Power P is dissipated by the resistor. And in time T, the energy transferred is E. Which expression is correct? So let's rewrite the two expressions that we derived at the beginning of this video. E equals QV equals I times T times V, and P equals I times V. So which one of the choices matches one of these two equations? Well, obviously choice A is correct because it's just like what we wrote at the top. I times T times V gives me the energy. And the other equations are all wrong. This is incorrect because energy is actually equal to power times time only. C is wrong as well because we said that power is equal to I times V without the R. D is wrong as well. So let's just take this chance to understand how to express power in terms of resistance. So we said that P is equal to IV. And we know from previous videos that V is equal to IR, or I is equal to V over R. So we can rewrite this equation in two formats. Either we keep the I and convert the V into IR, so it becomes I squared R, or, excuse me, or we keep the V as it is, and we convert the I into V over R. So P equals V squared over R. So we have two other expressions for power, which we can derive from the original equation. So P equals V over R, again, would be incorrect because it's supposed to be V squared over R. Therefore, the correct choice here would be choice A. The diagram shows three identical heating elements connected to a power supply. Which arrangement of switches causes the most power to be used? Well, this is a pretty logical question. Which arrangement would we be consuming the most power? Obviously, if all the three heaters are working. So the arrangement where the switches are closed, by the way, closed switches means that the electricity is running through the circuit. An open switch means that there is no electricity running. So if the three switches are closed, then all the heaters will be working, all the heaters will receive current, and therefore they will consume the most power. So the correct choice here would be choice A. The average current during a lightning strike between a cloud and the ground is 1.5 times 10 to the power of 4 amperes. The lightning releases 3 times 10 to the power of 8 joules of energy and lasts for 2 times 10 to the power of negative 4 seconds. What is the average electromotive force between the cloud and the ground? Right. So what quantities do we have here? We have that energy is equal to 3 times 10 to the power of 8. We have that current is equal to 1.5 times 10 to the power of 4. And we have that the time is 2 times 10 to the power of negative 4. So how do we figure this out? We remember the equation again. So energy equals QV or IVT. And we already know that the energy is 3 times 10 to the power of 8. We'll ignore this for now. We don't need this. So this is equal to the current, which is 1.5 times 10 to the power of 4 multiplied by V, which I don't know, multiplied by T time, which is 2, and 10 power negative 4. Now, if we simplify this, 10 to the power of 4 and 10 to the power of negative 4 cancel out. So we just get 3V equals 3 times 10 to the power of 8. If we divide by 3 in both cases, we cross out the 3 on the right, and we cross out the 3 on the left as well. We just have here 1 instead of 3. So V is equal to 1 times 10 to the power of 8. And the correct choice here would be choice C. A circuit contains a fixed resistor. The potential difference across the resistor is 24 volts, and the current in the resistor is 2.3 amperes. How much energy is transferred in the resistor in a time of 17 minutes? Again, let's write down our variables. V is equal to 24. I is equal to 2.3. T is equal to 17 minutes. I have to convert that to seconds. So 17 times 60. And that gives us 1020 seconds. We are looking for the energy. We're trying to find the energy. We said that the energy is equal to QV or IVT. I'm just going to write IVT because that's what we need for this problem. So energy is equal to 2.3 instead of I times 24 instead of V and 1020 instead of the T. So 2.3 multiplied by 24 multiplied by 1020 gives us 56,304 joules. So which of these answers is the correct choice? Of course, they are all, some of them are given here in kilojoules. Obviously, we want something that is 56 kilojoules, right? Because this is 56,000 joules, so this is 56.304 kilojoules. And therefore, the correct choice here would be choice C. The circuit shows a 12-volt battery connected to a lamp of resistance 3. How much energy is transferred to the surroundings by the lamp in 2 minutes? Again, energy equals I V T. I'm given here that V is equal to 12. I'm given that the time is 2 minutes, which is 2 times 60, which is 120. I'm not given I, but I'm given R. So we can use the equation V equals IR to derive I. Now V is 12. I want to figure out I, and R is 3. So therefore I equals 12 over 3, which is 4. So the energy here would be 4 instead of current, 12 instead of voltage, and 120 instead of time. So we just use our calculators, 4 times 12 times 120, and that gives us 5,760 joules. So the correct choice here would be choice D, 5,760 joules. In the circuit shown, the voltmeter reads 2 volts. A charge of 5 coulombs passes through the resistor in a certain time. How much energy is supplied to the resistor in this time? Remember our rule, energy equals QV equals IVT. It's important to figure out which variables I'm given. So I'm given the voltmeter reads 2 volts, so voltage is equal to 2. A charge of 5 coulombs. So C is the unit of coulombs, which is the unit of charge. And the variable that represents charge is Q. So I already have Q. So this time I do not need this equation. I need to use this equation instead. And the energy is simply 5 times 2, Q times V. So the correct choice here would be choice C, 10 joules. A torch has a simple circuit with a 3-volt battery and a lamp. There is a 20 milliampere current in the lamp. How much energy is transferred in 5 minutes? Energy is equal to QV equal to IVT. V here is equal to 3. I is equal to 20 milliamperes. So I need to multiply here by 10 to the power of negative 3. And this gives me 0.02 amperes. And the time here is 5 minutes. So that's 5 times 60. And that gives me 300 seconds. Now I plug all these values into the equation. So energy is equal to 0.02 multiplied by 3 multiplied by 300. So using your calculator, 0.2 times 3 times 300, this gives us 18 joules. So therefore, the correct choice here would be choice B. The potential difference is 12, the current is 2.5. How much energy is transferred in 1 hour? So E equals IVT. I is equal to 2.5. V is equal to 12. The T here is given in hours. So that's 1 times 60 times 60, because I have to convert it to seconds. So this is 3,600 seconds. Now I plug them into the equation. Energy is equal to 2.5 multiplied by 12 multiplied by 3,600 seconds. This gives us 108,000 joules. So the correct choice here would be choice C. Of course, it's joules, not watts, because we're measuring energy. Power is measured in watts, joules measures energy. So the correct choice here is choice C. A battery is connected to a circuit. It is switched on for 1 minute. During that time, there is a current of 0.4 amperes in the circuit, and the battery supplies a total of 48 joules of energy. They want the charge and the EMF. They want Q and they want V. So let's write down our given variables. The time is 1 minute, so 1 times 60, and that gives us 60. The current is 0.4 amperes, and the total energy is equal to 48 joules. We have E equals QV equals IVT. And you should also know, of course, that Q is equal to IT. And you can even get this by comparing the two equations together. If we remove V from both, we just get Q equals IT. So in order to get Q, we are going to multiply the current by the time. So let's do that. Q equals current, which is 0.4, multiplied by time, which is 60. And this gives us 24 coulombs. As for the energy, it is equal to I times V times T. So since the energy is 48, this is equal to the current, which is 0.4, multiplied by V, which we do not know, multiplied by T, which is 60. So simplifying this equation, we get, so I'll just write it down below. 48 is equal to 0.4 multiplied by 60 gives us 24. So 24V. Now 48 equals 24V. I can just divide both sides by 24 to cancel it out. And then I just get V equals 2. So the correct answer here would be the choice that has V equals 2 and Q equals 24. And this corresponds to choice C. So this is what we're going with. This brings us to an end of our video. Thank you for watching. I hope this was beneficial to you.